All right, so we're going to talk about reasoning with properties from algebra to kind of introduce a logical step-by-step two-column proof that we will be doing a lot in geometry. So this is going to kind of go back to the things that you learned in algebra and solving equations. So we're going to talk about some properties from algebra. Hopefully these are familiar. And then properties of length and measures to justify segments and length relationship, right? So when you solve equations, right, you can add, subtract, multiply, divide, same things on both sides of the equation, and it will still be equivalent, so it'll be equal. So that's what we do to solve algebraic equations. So these are familiar, right? So addition, subtraction, multiplication, division properties of equality, right? Now the reflexive and symmetric property are similar, but they're a little different. Reflexive is like looking in the mirror. It's like seeing a reflection on the mirror. It's exactly the same thing on both sides of the equation. So it's like identical, right? So think about looking in the mirror or thinking about looking at identical twins. It's exactly the same thing on both sides of the equation. So that's reflexive. Now, symmetric is similar, but it's a little different. Notice how this one has if and then. So if A and B are equivalent to each other, and then they may not be exactly same thing, right? But then you can switch it, right? Switch the location from the left side and the right side. And so that would still be equal, right? So the symmetric switches the left side and the right side of the equation. Reflexive is exactly the same thing on both sides of the equation, right? Transitive property is similar to what we talked about with the law of syllogism, where you compare three things or more, right? So notice how this is A and B are same, but B is also equal to C. So then the transitive property allows you to say that A is also equal to C because they're both equal to B in the middle, right? So you're making that transition, just jumping over the B because that's same. So then you could say A is also equal to C. So that's transitive property. Now the substitution property and the transitive property sometimes is kind of interchangeable, or sometimes you can use either one. Um, but the substitution property is a little bit different in a sense that you can substitute anything in the equation with something else as long as they're equivalent or something they're equal, right? So that's substitution property. If you're changing one variable or anything with something else that's totally equal amount or equal value. So that's substitution property, all right? So these are some properties that we're going to use to solve algebraic equations. And then we're going to kind of practice or set up a two-column proof that we're going to be doing in geometry, right? But we're going to use algebra first to kind of relate to some of the things that you've done with the algebra, right? So then we have a problem like this where you solve for the variable x, right? So the way you do the two-column proof is on the left side of the column is where you write the statements. These are the steps that you would take to solve the equation. And on the right side is where you write the reasons. And those are the reasons for the properties or definitions or anything else from the vocabulary or postulates or theorems that we've done and also we will continue to do. So these are the reasons that you can write following the step-by-step logical order to conclude. So here, if I'm solving this, right, you want to try to combine the variables together. So you want to add 3x to cancel this out. And then you want to add 3x to both sides of the equation. So negative 2x and positive 2x gives you 1x or just x, right? And then copy the plus 1 and then 56, and then that canceled out. So we got to here, step 2, by adding 3x to both sides of the equation. So that's the addition property of equality. So that's the addition property of equality is what we use to get to step 2, all right? So then once we get to here, we subtract 1 to cancel that out on both sides of the equation. So that leaves us with x equals 55, and that is our solution. So we got to the solution in step 3 by subtracting 1 on both sides. So that would be the subtraction property of equality. Right? So that's the reason and why or how we got to step 3. So that's kind of like an introduction to what we do with the two-column proof in geometry, but we're using algebra because this should be familiar to you in solving equations like this, all right? So the left side is the statement, step by step. It has to follow the logical order, obviously. And then the right side gives you the reasons or why or how you're able to get to that step, okay? Let's take a look at another example. This is just what I just did right now. Okay. So if I'm solving this, right, the first thing we do is distribute the -3 there. So the second step would be 12x, and then distribute the -3, and then distribute the -3 will be -21, and then the other side. So we got to step 2 by doing distributive property. So that's the distributive property. Now, that wasn't on the first page that we just looked at, but hopefully you're familiar with distributive property, right? So that's the distributive property. So we use the distributive property to get to step 2. So then now here, we want to combine like terms on the left side of the equal sign here. So the 12 minus 3 is going to be 9x, right? So 12 minus 3, x is going to be 9x, and then copy the rest. So we're just going to do step by step. And so we were able to get to 9x minus 21 by combining or simplifying by just subtracting these two. Now notice this is not the subtraction property of equality because we didn't subtract 3x on both sides. We just subtracted 3x from 12x to simplify these two, right? So this is what we call simplify. So that's different than subtracting 3x on both sides of the equation. So that's not subtraction property of equality, right? Because we didn't do that on the right side. So we simplify by combining the like terms here. And then the next step is to move the 9x to the other side or move the 8x to this side to bring the x's together. So we're going to we could do either way, but I think it would be easier if I subtract 8x to, subtract the smaller number from the bigger numbers. That cancels out, so you get a 0, right? And then 9x minus 8x is 1x, so just x minus 21 is equal to that. Cancels out, you get a 0. So make sure you put the 0 there. So that's step 4. And so that we were able to get to step 4 by this time we were subtracting 8x on both sides of the equation. So that's the subtraction property of equality, right? Because we did that on both sides. So that's the subtraction property of equality with the equal sign for that, right? So then the next step should be easier, right? So we add 21 to cancel that out on both sides. So now we're adding 21 to both sides. So then we get x equals 21. That's our solution. So we got to the solution to the end by adding 21 to both sides. So that's the addition property of equality. Okay. So you probably didn't write the reasons when you did the problems like this in algebra class, but you probably are aware of some of those reasons or properties, even though you might not have to write it, right? So this is how we set up or we do the two-column proof in geometry. And you're going to be doing a lot of these, of course, in geometry and using geometry properties and postulates and definitions and theorems. But this is a good introduction to how you do the two-column proof. So again, the left side is the statement in logical order, step by step. And then the right side just gives reasons or explanations of how you got to that step, what you did to get to that step, right? So that's the algebraic properties and reasons how we were able to solve that, okay? So that's again, using algebra to kind of show two-column proof, right? So that's the same thing that we just did. So here is another example of converting a formula like this. If you remember, this is the formula for the temperature, Fahrenheit and Celsius, right? So to convert from any Celsius temperature to Fahrenheit, you just plug in into this formula here, whatever the Celsius temperature is, you plug it in, and then you multiply by 9/5, and then you add 32, and then you get the Fahrenheit. So then what if I want to go backwards? What if I want to go from Fahrenheit to Celsius? Well, so then I can change this, right? I can transform this formula so that I can get the C by itself. And so that's what I'm trying to do here. So first step is given. So we always start with sort of the given equation or the given problem, right? So the first step in the problem is kind of given to us. So that's given. And then to go from here to solve for C alone, I need to get rid of the 9/5 to get rid of 32. So I subtract 32 first on both sides, right? So that cancels out. So then F minus 32 is on the left side, and then I have 9/5 times C. So we got to step 2 by subtracting 32 on both sides. So that's the subtraction property of equality. And then from here, I got to get rid of this fraction here. And if you remember, whenever you have a fraction, you can get rid of the fraction by multiplying by the reciprocal. So the reciprocal of 9/5 is 5/9. And then we do the same thing on both sides. So we multiply by 5/9 on both sides of the equation. So that's why we got to here by multiplying 5/9 on both sides of the equation. That's why this is multiplication property of equality. So what happens is that the 5 and 5 cross cancels, right? 9 and 9 cross cancels. So technically, when you cross cancel, these are all 1, right? So then you get 1C, which is just C, right? And that's how we were able to get the C by itself. And so that's 5/9 parentheses times F minus 32. So that's how we were able to transform the equation from the Fahrenheit formula to the Celsius formula by, doing the subtraction first and then doing the multiplication of a fraction on both sides. Because whenever you have a fraction, you multiply by the reciprocal, right? So again, that's just algebra steps, but we are practicing how we set up the two-column proof. Again, the left side is the statement in logical order, and then the right side is just reasons or how you are able to get to the next step, either using properties or other definitions or postulates or theorems that you'll be seeing more in geometry. Okay, so that's how we do the two-column proof. Then we have a few more properties that we're going to be using more with the geometry now. So this is similar to the reflexive property and the symmetric property and the transitive property that we just saw in algebra. But now we're going to apply it or use it for geometry, right? Or using geometry, measurements that we talked about already. So here for the length of any segment, right? Notice that AB is exactly the same as AB. So that's reflexive, right? You're looking at a kind of reflection on the mirror, exact same thing, right? Same thing with the angle. The measurement of angle A is exactly the same thing as measurement of angle A. It seems kind of silly sometimes why you would, even put this, but you'll see later on why we need to do this. So whenever you put the same thing equal to the same thing, that's reflexive property of equality, okay? Now, symmetric property of equality is similar to what we saw earlier, except now we're using the measurements, right? So if length AB is equal to CD, you can flip that around, and then that would be same thing as saying length CD is equal to length AB. So symmetric is just switching the left side and the right side of the equation using the if and then magic words there. Same thing with the angle measurement, right? Measurement of angle A is equal to measurement of angle B. Then you switch it around, then you know that measurement of angle B is going to equal to measurement of angle A. So when you flip the two sides of the equation, that's called symmetric, right? When it's exactly the same, that's reflexive. So the transitive, again, is comparing three things or more. So notice we're comparing AB with CD and EF. And notice the CD and CD is exactly same in the middle, right? So since they're both same as CD, that means AB is also going to be equal to EF. Seems kind of obvious, right? So again, when you make that transition, when you make that jump, right, skipping the middle part because it's same, that's transitive property of equality, right? Same thing here with the angle measurement. Notice A, B, and B is same, and then C. So we can skip the measurement of angle B and say measurement of angle A is also equal to measurement of angle C. Seems kind of obvious, right? So that's transitive property of equality if we're using, you know, length in geometry as well as measurement of angle in geometry. Okay, so let's see how that can be used to do two-column proof of something like this. So again, some proofs are not going to be this long. This happens to be a little long proof, but not every proof is going to be this long, right? But let's see how we do this one here. So we're trying to find the measurement of angle 1 given this information here. So we're given a lot of information here. We've given 3 equations, right? So you start with the given information. So this is basically copying the information here on the top right here. So copy the first equation, so that's given to us. Copy the second equation, that's given to us. Copy the third equation. So you start with the given information, whatever is given to you, right? And then just remember, we're trying to find the measurement of angle 1, right? So that's what you should be trying to get to, right? So this might look kind of confusing, but what I'm going to do is using this right here, since measurement of angle 1 is equal to measurement of angle 4, I'm going to substitute this with measurement of angle 4. Remember, when two things are same, you can substitute one for the other. So instead of writing measurement of angle 1, I substitute that with the measurement of angle 4 here. Okay. Now this came from the second step here, since I also know that measurement of angle 2 plus measurement of angle 3 is also equal to measurement of angle 4. Notice here, these two, I can substitute with the measurement of angle 4 here. So that's the second substitution, where the measurement of angle 2 plus measurement of angle 3 is equal to measurement of angle 4. And then the measurement of angle 4 is just same, so just copy that there. So that's the substitution property, because I substituted something that was equal instead of the first line. I substituted each one here with the measurement angle 4 because they're all equal to each other. Okay. Now, since these are all measurement angle 4, if I add all 3 of these, it's like having 3 times the measurement of angle 4, whatever that is, right? So if this was like x and x and x, this will be 3x. So it's like that. So that's simplifying by just basically adding all those same numbers together. And then I divide both sides here by 3, right? So I want to cancel out the 3 and then divide that by 3. So that's the division property to get to measurement of angle 4 because the 3 canceled out. And then 360 divided by 3 is 120, right? Now, this is where you could use transitive property, or you could also use substitution, because if you look at measurement of angle 4 and measurement of 120, right, if you're using transitive property, the measurement of angle 4 is here, but then we know that the measurement of angle 4 is also equal to measurement of angle 1, right? So I transitive property from measurement of angle 4 to measurement of angle 1 here. Okay, so I'm going from measurement of angle 4, which is same thing as measurement of angle 1. So then that's what I did. So you could use transitive property, or I could just say substitution as well. So I could do substitution, right, property, because I could just substitute measurement of angle 4 with measurement of angle 1 because they're equal to each other. Just like I did here, I substituted measurement of angle 1 with the measurement of angle 4. Now I'm just going backwards, right? I'm substituting measurement of angle 4 with measurement of angle 1 because they're equal to each other here. So like I said before, transitive property or substitution property, are usually interchangeable. You can use one or the other because they will both work together in most of those cases. Okay, so that was kind of a long, proof in the algebra uh, equations here, but not all the proof in geometry will be this long. Some will, but this is probably as difficult as it would get with this many steps, right? So again, two-column proof, statement in logical order. So each step has to kind of follow logically from whatever you have in the previous steps, right? And then you just write the reasons or how you got to that step, right? Okay, one more. So here we have a diagram with all these different segments. And then it tells you here that the B is the midpoint of segment AC, which means that the B is in the middle. So that means AB and BC is going to be congruent. Remember, if there's a midpoint, right, by definition of a midpoint, these two segments are congruent. So that's kind of going back to our vocabulary with the midpoint right before. And then it also says C is the midpoint of BD. So then not only B is the midpoint, so these two are congruent, but C is the midpoint of BD. That means the BC and CD are also congruent. So in other words, all three of them eventually will be congruent to each other. So we're supposed to show step by step AB is equal to CD. The length AB is equal to length CD. So we know they're going to be all congruent, which means that by definition of congruence, that they're going to be also equal measure, equal length, right? So we can kind of mark along the picture as we go down the logical steps here to use it on the proof as well as mark it on the picture. So we start with the given information that B is the midpoint of AC, right? And that tells us that AB is congruent to BC. That's what I marked up here. That's by definition of midpoint, right? We did that a while back when we talked about midpoint, okay? So anything that we did on a vocabulary and that information helps us to find something like this or write something like this, you would always say definition of those vocabulary, okay? That's why those vocabularies were so important. We did so many of them. So you need to kind of go back and review your vocabulary once in a while to, kind of review everything because, you probably forgot a lot of things because it comes back over and over again, especially the ones that deals with segments and angles, right? So then the second part, the C is the midpoint of BD, that tells us that, BC is congruent to BC is congruent to CD, right? So that's the other definition of midpoint, right? So that's the BC congruent to CD. We already kind of marked it. Now, another important thing that we talked about this a while back is as soon as you say that the two segments are congruent, right? That's basically same thing as saying that the length of those segments are equal, right? And so that's the definition again of congruent segments. So anything that's congruent, that means they're going to have equal measure. So as soon as you say the two segments are congruent, you can turn around and say that two lengths are equal. And you can go vice versa as well. So if two lengths are equal, you can turn around and say two segments are congruent. You're kind of saying the same thing in a different way, but that's what the definition of congruent segment means, right? When two segments are congruent, that means they have equal length, right? Same thing here, right? So as soon as you say they're congruent, right, you say that the length are equal. So remember how we know that there's a difference between segments with the segment bar being congruent and then the length without the bar being equal. So make sure you're grammatically correct. Again, that's the definition of congruent segments again, right? So then using the transitive property of equality, so that's using the step 2 and step 4 together. So we start with AB and then we go to BC, right? So we start with AB and then AB is same thing as BC, but then notice BC is same thing as CD, right? So kind of like our law of syllogism, right? Transitive property skips and jumps over from the beginning till the end because the middle part, BC, is the same. So then we can say AB is also equal to CD, and that's what we're trying to prove right here, right? So we were able to prove that on the last step. So then we're done. And we got to here using transitive property of equality, right? Again, I could have used the substitution property here as well. I could have just substituted BC with AB here, right? Because BC and AB are equal to each other. Again, so transitive property and substitution property, they kind of go hand in hand together. You can use either one of them because they kind of both work together on most of those cases. Okay. So that's how we do two-column proof. So I know that you probably did a lot of algebra steps before, but you probably didn't do a lot of reasons on the right side with two-column proof. But that's what we're going to be doing a lot, and that's what makes the geometry really challenging and also interesting, because this is where we really get to test and try out our logic, because your proof has to be logical in order, right? And so that's where our logic and step-by-step proof with reasons is going to really kind of test our thinking level and our logical step-by-step. Okay, so that was the introduction to algebra and two-column proof. Okay, all right, thank you.